In this video, we will talk about our constitutional isomers for alkenes. We've got positional and skeletal isomers. So for alkenes, you're going to have more isomers possible than we did for alkanes. And not only are there more total, but we have different types. So for skeletal isomers, our first type here, they're constitutional isomers. I remember isomers in general have to have the same formula, so same number of carbons, same number of hydrogens. And these are going to be different based on the carbon atom arrangements. So this is much like the isomers we saw for the alkanes. The carbons are arranged in a different way. It also means the functional group is going to be somewhere different, but it has to still be the same functional group. So if you have a double bond, you're going to end with a double bond. For positional isomers, again, same formula. But in this case, we actually do have the same carbon-carbon atom arrangement. The difference is just the location of the functional group. So in this case, our double bond is just going to move. So here's an example. So 1-butene and 2-butene are what type of isomers? So let's go ahead and draw these out. Butene is 4 carbons. Here's 1-butene, double bond starting on carbon number 1. And here is 2-butene. So in this case, we've got the same formula, so they are going to be some type of constitutional isomer. Positional isomers were the ones where the double bonds move, and in this case, that does happen. And the carbons are not moving. There's still just 4 carbons in a chain. It is not skeletal because the carbons are not moving. And positional skeletal isomers are not something that exist, so it must be letter A, which is the correct answer. Here's some more examples. So we're going to decide if these are positional or skeletal. So let's do number 1 first. We have 1 hexene. So there's our hex, double bonds on carbon number 1. Second one is 2 hexene. So in this case, hexene, it's our longest carbon chain is 6. The only thing that changes is the location of the double bond. So these are positional. Notice you can tell this by looking at the name. If the base name is the same and you don't have any substituents named or the substituents stay the same, the only thing that changes is the number of the double bond. If that's the case, then it will be positional. In this case, the number 2, pentene, in both cases. 1 pentene means the double bond doesn't move. What is changing is the location of the methyl group. So 2-methyl versus 3-methyl. So let's go ahead and look at these. So we've got 1 pentene, methyl group on 2. 1 pentene, methyl group on 3. So here, what is changing is the location of a carbon atom. So these are going to be skeletal. Last example, pentene, the double bond does move, goes from 2 to 1. The substituent 3-methyl does not move, so the only thing that is changed is the location of the double bond, so this is also positional. Here's a couple more examples. You're given line angle, so take a minute to decide if these two are positional isomers, skeletal isomers, or not isomers at all. So the first thing we need to check is we want to try to eliminate the not isomers by making sure our formula is the same. So let's count our carbons. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. The other one, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So both have 14 carbons. They both also have 1 double bond, which means it's going to be the H2N. So that's 28. That's true for both of them. So we have the same formula. So they are going to be isomers of some kind. So we can eliminate that last possibility. If we look at this, we see the double bond does move. Our groups are different. Here I've got 2 methyls on something. depending on where my longest chain is, which is something you're going to find out. So it's not the same structure with just the double bond moved. So these must be skeletal isomers. If we name these, it's going to be a good check because we know how to, from the last slide, how to recognize just within the name what type of isomer it is. So if I want to name the one on the left, good practice anyway, I can number left to right. Don't fall into the trap and just go straight across. That would only be 7 carbons. If I go down, I actually have 8 as the longest chain. If I go left to right, so green puts the double bond on 5, blue puts the double bond on 4, so blue wins. I have an ethyl group, another ethyl group, and 2 methyl groups. So ethyls come first alphabetically, so I've got 4,5 diethyl, and then 2,2 dimethyl, and then the double bond starts on, actually it starts on 3. I mistaked that earlier, it's not 4, it's 3. So we've got 3, 8 is oct, double bond is ene. So 4,5 diethyl, 2,2 dimethyl, 3 octene. This last example, if I go left to right, versus right to left, green puts the lowest double bond on 3, blue would have put it on 5, so green wins. I have 3 methyl groups and 1 ethyl group, so ethyl is listed first. I've got 4 ethyl, and then 3, 5, 7 trimethyl, 8 is oct, and then ene, and I need to remember my number, which was 3. So 4 ethyl, 3, 5, 7 trimethyl, 3 octene. So if I look at the names and compare them, they're both 3 octenes. So the double bond appears to not be moving. What is moving are the substituent groups. So I'm going from 1 ethyl group to 2 ethyl groups and a number of other changes. So carbons are moving around. It is in fact a skeletal isomer. So those isomers are going to take some practice. So work carefully through the problems in the homework as well as any extra problems that are in the textbook if you need the extra practice. The next video we will talk about Sis Trans Isomers, which are a different type of isomer from the constitutional isomers that we just looked at.